Hi, so I wanted to continue the dev blog that I started over the summer. The school year started and our team has been formed. We're currently a team of 7 programmers and 2 sound designers, and we're hoping to get some artists in as well soon. So our game concept is a space shooter racer hybrid, and we are really focusing on getting Oculus Rift support so that the game is really intended to be played with the Oculus Rift, really the whole thing kind of focused on VR support. And so in the last video I showed you how we can edit the GUI at runtime. In this one I'll show a few more features of our engine now that it's starting to get started, and in addition some more cool stuff you can do with runtime compiled C++. So here we're just going to be editing in assembly. In many other game engines you'll hear this referred to as a game object. So an assembly can contain scripts, components, and subassemblies. Scripts give the assembly some behavior. For example, you might have AI game logic here, or just whatever general game logic you want to attach to an assembly. A component will interact with certain systems. So for example, the physics system in order to give it the ability to be moved by forces, or the graphics system so that it can draw itself on the screen. And finally we have subassemblies. These can be thought of as just regular assemblies, however they're children of this main assembly. And being a child means that its position is actually relative to its parent. So for example, if the parent was at position 5,5 and the child went to position 0,0, it would actually be in the world position 5,5. And you can just keep adding children as you go along, and every child will be relative to its parent no matter how many layers deep you go into the system. Another nice thing about this is that it allows you to easily separate your assemblies into modules. Because what happens is if you have a game object system where it's flat, you'll end up with some objects which end up having a ton of components and a ton of scripts attached to them, and it's hard to sort them out. For example, the player object might end up with a player controller as well as the regular stuff like a rigid body, etc., and it just adds up and becomes very hard to manage. Here we can separate stuff into nice modules. For example, our ship might contain a left wing which contains an engine, and we can put those all into separate subassemblies in a way that makes more sense logically. So now I'm going to show how we can edit stuff at runtime. So we have the concept of an editor tweakable. An editor tweakable is simply a variable that can be shown up in the editor. So for example here, 1 is actually this same integer. Now what's cool is that we can actually add an editor tweakable with runtime C++. In fact, we can add an entirely new variable to a class and have it show up in the editor immediately. So you see by recompiling here, we immediately, well, the first time it takes a little bit of time for things to compile. Just bear with me here. There we go. So it shows up in the editor right here immediately. So that's really very useful and something you normally couldn't do. So I also want to show that we can actually save the state of an object in between compilations. So for example, because what happens is when runtime compiled C++ recompiles, what it'll do is it'll actually swap out your objects and create a new one. That's why, as you can see, we can add this new editor tweakable because the onConstruct method gets called again, and this only gets called when the object is constructed. However, I've also made it so that we can save data along between swaps. For example, I'm just going to change these two objects here, save it out, and even though normally this would be reset, now you can see that it actually saved its state. So that's pretty neat. We also have the serialization system here. Things in here will be written to a file, and these are just they won't be written to a file if you decide to if you decide to serialize the object. These won't be written to a file. However, you can save this data between runtime swaps, so that can be useful if you just want an object, if you just want something to be saved only between swaps, but you don't actually usually need to save it to a file. And so the real nice use of this is that, let's say you're developing the game and you're in the middle of this giant ship battle or something, and something about the enemy logic, just you think you could tweak it a little bit. So normally in many game engines, what you'd have to do is you have to stop the whole battle and then change your script and then start again, and then you'd have to kind of set up the whole battle again, and you're probably not going to get it back in exactly the same state it was unless you serialized everything. In short, you have to take some care into getting yourself back into that same state. But now we can simply just change the logic. We can pause the game, change the logic here, recompile it, and continue the game. And actually, while the behavior of the object has changed, its state has been saved between compilations, which makes that a much smaller hassle and lets us try out changes while the game is running really easily. So that's pretty much it for now, and hopefully in the next update we'll have some graphics and some pretty things to show you, so it'll be a little more interesting. Thanks for watching.